Okay, welcome to the first lecture of our course, Manual Testing plus Internship, MTI 2002.3. Okay, and our first lecture is just the introduction to the course that link it with like all the topics of the course, and I think gives a whole picture. What are we doing as testers? Who are testers? What is the main mission of the testers? So the beginning. And here is our today's plan. We will start from a bit of history of software testing, just to go a bit deeper into this and to make an impression where and when the testing started. And then we will consider the software testing basics, like what is program and quality, and what are the bugs, typical places, and why our course looks like that, looks like we imagined. What are the testers' tasks and the place of testers in a development team? Who are who in development team, and why testers should be friendly with all that guys? So let's start from a bit of history of software testing. Probably you all know the event that opened the new page in software development, and this page called the software testing. In 1947, there is a woman named Grace Hopper. She lived in US and she worked for US Army. She was a first programmer. She had a huge computer in her room, and she, for example, created the first compiler and a first compiled program. But we, as testers, remember her because she found the first bug. Probably you know that story about the first bug when the Grace Hopper came to the work one day and saw that all her subordinates are trying to repair the computer. The computer is not working, everybody is very sad, and nobody can understand what's happening. And he asked, guys, did you watch inside the computer? And they answered, no, we didn't. So please do, asked Grace Hopper. And they watched inside and found that little bug inside on one of the relays. And Hopper took this bug and said, oh, this is a bug. So that was the first bug. But don't think that that was the beginning of testing how we know it currently, because the testing itself began in 1979 when the famous book, The Art of Software Testing by Glenford Myers came to the world. Before this book, all the testing called debugging, and all that testing were doing by programmers only. So we had no testers like a separate profession before this book. But Glenford Myers said that it is not normal when programmers are trying to test their own programs, because that's like you will test your own child. And you will think why your own child is bad. It is not normal for any human. And that's why some separate people, some separate professions should be, some separate people should test the programs written by the programmers. And he, on the basis of math, he created methodologies for testing, methodologies for how we can test everything without testing everything, how we can cover all the functionality without spending a lot of time. And that methodologies came to the world in 1979, but we are still using them. All our test design methodologies are from this famous book. And that's why I always advise you to read the book, because this is our Bible, the Bible of the testing. But it was the Bible, but it was not a standard. And the first testing standard is from 1987, where some smart men and women created the standard how to write test cases, how to write test plan, what is testing itself, all that definitions that we have that are from this software testing verification and reliability standard. And right now we are applying this standard when our process is stable, when our process is mature. When we are doing normal testing, not like we are testing on prod and we don't know what to do. And about the modern testing, what I can say about the testing currently. Now the testing is a huge profession that has a lot of branches. We have automation, we have manual testing, we have functionality and performance and pen testing and so on, so on. So now this is a profession that is divided into different small branches. And on our course, we will learn manual functional testing, not more. But after you will be manual functional testers, you can choose any branch. So this will be your basics. Okay, so about definitions a bit. So what is a program? You can open any vocabulary and read there that the program is a set of instructions for a computer. And that's true. But what if we will call our house a set of bricks connected to each other with a cement? It will be absolutely right definition, like the program is a set of instructions for the computer, but the definition says nothing about what is the house for, what is the program for, what will be the users of a house or a program. And if we will stand on the point of view of users, we will say that the house is a building for people to live, and the program is an application for people to help them. Okay, so one of the points of view that we are standing on as a tester is the user's point of view. And even if we are doing some technical investigation, some technical testing, we always should remember about the end users, because we are like advocates of the end users. Developers are not the advocates, the end users. Developers are just writing the code and they are doing nothing except it. And they are not needed to think about the end user, because this is our job to think about them. Okay, so we are now talking about the program and about the end users. So what is the quality? We are testers and we should assess the quality of the program. So what is the quality? What is the definition? And what is it all about? We have the great phrase from Sam Kanner that is quality is a value for some person. So what does it mean? Quality is not absolute. Okay, quality is different for different users, for different groups of users, for different groups of software. We will discuss it on the next lectures of test design module. So an example, for example, you are a mom of teenager, or those who were teenager not so late, you can think about you as a teenager. Or if you're a mom, think about your child. And think about the room of your teenager boy or a teenager girl. And what is the order for your teenager girl? Probably the order from the point of view of a teenager is shown on the left picture. But if the mom of this teenager can see that order, she thinks that this is not an order at all, because the order should look like the picture on the right. So the same room, the same view, but different end users, different different humans who are living in this room, and different definition of quality. And we have the same with the quality of software. If we are doing the software for like some system administrator, for example, for any system administrator, it doesn't matter if the software is beautiful or not, because the command line is typically enough for any system administrator. And
yes, and
yes, Fyodor, this is especially for you,
sorry
because you are here.
Yes, right.
Yes, but imagine some beautiful girl who are trying to buy a dress in some internet shop, some e-shop. And I think the command line is not enough for her. He wanna see some beautiful site, some beautiful page, beautiful buttons, and it should be comfortable for you and for her. And she should have a good impression from the interface. So different software and different quality. No interface for system administrators, and a beautiful interface on the other pole for some beautiful girl who are buying some things in the e-shop. So we always should have in mind this definition of quality for your particular end users. So, okay, we now understand what quality is, but what the defect is, and how to understand the impact of some defect to software quality. We have these pictures here with this teenager girl and her mom. If our target user is a teenager girl, we will be thinking in what cases she will be sad. If her mom will be sad, it is okay for us because we are doing our software for this teenager girl. So if we have a defect that has an impact on our particular target user groups, and we know it, we should think about this defect as a defect with the highest priority. If not, probably it is not a defect at all. So in order in the room for a teenager girl, it is an order. And if something will be not on the place, it will not be a defect itself. Or probably this is a defect with not very high priority, so it's low priority or something, okay? But we're now talking about the user interface. and the defect that we can observe on the user interface. But how our real program looks like? Is that a user interface at all, and that's all, or we have something inside? And how it could be impact our users, all this architecture of our program. So firstly, imagine that now we are imitate users and we see errors on UI. Errors on UI could be linked with the user requirements. This is our document in the vacuum. So this is our document that we are comparing our software with. This is a document from business, from product owner, and this is something that we can be against these requirements. And we can observe on our UI that some requirements are broken somewhere, okay? Some user interface is not according to the requirements. Except the requirements, we can see a breaking of a class of products. For example, you probably all use Windows applications. Sorry, Fedor. I will talk about the Windows application because this is the good example of class of products. Probably you remember in what order do we have the OK, cancel, and help buttons in any Windows application? So we firstly should have OK, then cancel, and then help. No other order. But our requirements, business requirements, technical requirements, any requirements that is written by your analyst team will not mention the order of the buttons in the Windows application. Because everybody knows that this is a class of products, and in any Windows application, we should have OK, then cancel, and then help. No other order. So if we see on your user interface the buttons in different order, you can think that this is a defect because this is not according to class of products. Windows applications, this is the big class of product. And the common sense. When we're talking about the common sense, we primarily have in mind the usability or the UI, so the design of the application. For example, if you are implementing some software for accountants, and that poor accountants should do some daily operation like closing some tasks or something, and to do this daily operation, that poor accountant should press 3 buttons, then open some modal windows, then press 4 more buttons, and then this daily operation will be completed. It will absolutely not comfortable for your users. And this is a common sense, because probably you have nothing about that in the requirements, you have nothing about that in the class of products, but this is the common sense. And if something is not according to the common sense, this is the defect again. So we can have some defects on the UI. Then we can observe as a user that is not according to the requirements, not according to the class of products, and not according to the common sense. And again, these defects can be observed, but we really don't know where the root cause of these defects. We can just observe the result of the defects, okay? We can call it defects. In some literature, you probably can meet errors and defects, and errors means the result. So the result we can observe, but what does it really look like? So the application. The application is like an iceberg. Probably if you were on my webinars and Fedor's webinars, you probably heard it already, but let me repeat again, that the application is like an iceberg. And about 10% of application is visible above the water. And 90% of application is under the water. That 10% is your user interface, is the part that you can observe as a user. And all the other things are covered by the water and you cannot observe it like as a user. But as only 10% of software is visible, only 10% of issues are visible for users. So for example, if you press some button and nothing happens, or you see some error message on the end user interface with some absolutely strange words that you cannot understand, absolutely you can do absolutely nothing because of this message, so because you cannot understand it at all. This is the issues that can be observed by the user. But despite on you should from time to time stay on the point of view of the users. You as well should understand all the issues that are linked with the part of the application that is covered by the water, that is not visible for the end user. So 90% of issues are much deeper than the user interface. These are services issues, network issues, database issues, integration, software environment, etc., etc. And your mission as a tester is not only be an end user and press some buttons on the user interface. Your mission is to understand, even if you pressed some button and even if you see something on the user interface that you don't like, your mission is to understand where exactly is the root cause of this strange message, for example, where to find the broken part. Is it services or is it network? Is it database? Is it integration? And it can be absolutely everything that I meant, even if you see the result on the user interface. Okay.
I'm sorry, I would want to add some few words here. So, Tim, you may see at the top of the picture, and you will see that on the every 10th bug is really related to UI. But unfortunately, in the QA industry at all, very many people and even very many companies are focused just on this part of iceberg that is visible above the water, and all remaining bugs that are really interesting, that are much deeper and that are much harder, remain uncovered and remain hidden, and really nobody cares about that. And moreover, very many companies even don't believe that any QA engineer can find something difficult, for example, on the level of integration or in the layer of database and so on and so on. Our main goal during the course is to make you as honest and true software engineers who really understand the whole picture and who can find bugs on every levels, and we will do our best to eliminate any considerations like, oh, it's a black magic, so I don't want to dig deeper, so I would want to stay with UI. No, so the most part of interesting things are really covered under the water, and we'll try to show you how interesting such things are.
Thank you, Fedor. Absolutely agree with you. Okay, guys, maybe it is time to ask you if you have any questions, because I'm just started and going very fast because I've been late today, unfortunately. Is everything clear for now?
I think, yes, it's clear.
Yes, okay.
Everything is clear, no questions. Thank you.
Mm-hmm. Okay, just to clarify everything, please, guys, if you have any questions, just don't be afraid to interrupt me, okay? And to interrupt any other lecture, because we are here to conversate with you. So we are not here to be some speaking head, like we can ask you questions, and please ask your questions by voice. Okay, Julia sent me a thumb up. Okay.
Hello, I have one question. What is software environment issues means? I understood all the issues, but software environment have some questions.
Okay, Vyacheslav, thank you for your question. We will discuss it later in the course, but today I can just briefly explain what is it. We have some special computer, special cloud that we call testing environment. And in this environment, we are imitating the conditions that our real software will have on production. So the same operating system, the same integrated software, if we are having some integration with some other software, network conditions, and so on. And we are doing it to test not only the software itself, but the platform our software is laying on, okay? How is it communicating with the operating system? How is it communicating with some other software that is needed for this? How it is communicating with some platform our software is based on? For example, some not all maybe, most e-commerce applications, that e-shops that you are using are based on some platform. It is not written from the scratch. They are based on some pre-written application that we are taking and customizing and doing our own e-shop from this. And when we are communicating with this platform, when we are integrating with this platform, we can have some issues. So all that is our environment.
That's right. So I can add a few. I can add a few samples here. So you know that when we test any applications, we consider that the application doesn't hang in air, and such application is executed within some operating system environment and so on. And imagine what if your operating system runs out of space, or when your operating system runs out of memory and begins to swap. And for example, when the processes and services eat too much memory, and when it begins to swap, you will definitely see huge delays in processing speed, because such operations of exchange your memory blocks from your operating system to your hard disk are really very expensive. For example, such two cases, run out of space and run out of memory, maybe they are the most typical and the most clear to imagine.
Vyacheslav, did we answer the question?
Yeah, now I understood. Thank you.
Thank you. Any other questions? Okay. So remember the previous picture with that bug and the user interface, and then imagine that we view the same picture, but from the other point of view. And here are 4 defects, and these are the defects. And these are the reasons of our defects. So this is our software, user interface, and the software inside. And probably this one is maybe this one, I don't know. And its reason is defect from services, for example, then another defect from services that is linked with this one, and 2 defects from the database that are linked with these services defects, or maybe the reason of these services defects. And because of all that 4 reasons, we have this result on the user interface. So you see the result, and you are, as a tester, should know the reasons of this result. You should be able to find all these angry bugs inside the application. And what about these 2 defects? You see 2 results on the user interface. For example, you cannot add the user to the users list somewhere in the application, and you can't, update some description of users, position, for example, in the other part, on the other page of the application. And we can think that are 2 different defects, and they are not linked with each other, because this is the user's list, this is the positions description, and we can't update the position, we cannot add the new user, and how all that are linked with each other. But in real, we have the only one reason of these 2 results, because our user cannot make changes to the database, because he or she has no rights to manage the database. And we are trying to manage the database when we are trying to add new user, and we are trying to manage the database when we are updated the position description. But the reason is the same. We have no rights to manage the database, but 2 different results on the UI. And you should write 1 defect, not 2, if you see such things. Okay. And this one is only about the UI. It could be as well. So not all the bugs impacted by some other reasons inside. We can have some UI defects. For example, the button has not proper color on the UI, or the size between the distance between 2 buttons is not according to the documentation. This is the UI bug, and you cannot, you have no reasons to go deeper, to find something inside. And when you will be an experienced tester, you will know when you will see that results on the user interface, you will know, or you can just suppose if this is the interface defect, or if this is the services defect, or maybe this is the database defect or defect of the integration. This is about the experience, but we will give you a basics for to start this experience. Okay, you will have the knowledge, and you will have the start point to get this experience from. So,
Lilia,
okay, yeah.
May I ask a question about 3 bugs in the middle? If we have bug in database, for example, which leads to 2 errors on user interface, how should we describe it in bug report? I mean, we have 2 actual results, and we should have 2 expected results, or we should describe 1 bug only, but in the field of actual result, there will be 2 lines.
Yeah, got your question, and thank you. It's very interesting, really. So when we have such a picture, we should create a defect for the database team, because we probably will have some separate developers who are only managing the database and not touch the user interface. So we will create the bug for them, for database team, and we will describe the reason there. So we will describe this one. So the no rights for the user to manage the database, then description of this database reason. Probably we can try to send a request to the database directly without the user interface, without services, just by using SQL. And we will describe the steps how to check it from the database. And then after this typical description, like steps and expected result and actual result, we will describe how it is impacting the user interface. So we will add impact to the user interface, double dot, and then case 1 and the description of the case 1. Then case 2, the description of the case 2. So the case 1 will be about the list of the users, and that you cannot add somebody to this list. And the case 2 will be about the updating the description of the position. You cannot update it. And probably it makes sense to add some description of services there as well. Okay, so we will be doing it all during the course. So, but thank you for the question right now. Did I ask?
Okay, thank you.
Any other questions, guys? Okay. So how to understand? To understand. I have a defect here, sorry. How serious is the defect? Customer will be sad anyway, but it could be more or less sad about this defect. So if we are talking about user interfaces and the reasons that we can observe on the user interface, it is understandable, especially if the feature is very important. We can suppose that customer will be sad and the bug should be fixed in like 2 or 3 days, not more. And if we have some defect that looks serious, like application crash, for example, it is understandable as well. This is a serious defect, application is crashing, and probably the customer will be sad because of this crash, and we can no doubt about the priority of this defect as well. But if we remember this picture, some defect could look easy, look light, like, and we could think that it is not so serious for the end customer, for the end user. But if we will know all that reasons of this defect, and if we will know that we have a lot of inside problems with the database, with services, whatever, we can think that, okay, this particular defect, this particular result on the UI looks not very serious, but because this is the result of more serious problems inside, probably that problems will cause more defects on the user interface, more defects that make our customers sad. And if we know all this information, we can suppose that this bug looks easy, looks light, yes, but this is a serious bug. This is a bug with the highest priority because the reasons of this bug is are very serious, and we should underline it in our bug report. And that's why we should know everything about the application and the operating system and the service and so on. So about the integration and about database, so on, just not to miss serious defects, and just to be able to provide all the information that we have about this particular result that we can observe. Fedor, I stole your slide. Okay, 2 slides, so sorry.
That's okay. No, you haven't. So you haven't cheated. So you just reuse it.
You can proceed with your slides if you want. What the first one and the second one. If you want you wanted to stay on this slide yourself, please.
So I would better
feel free.
return such slide to you, because I don't know your intentions of which material do you want to explain here.
Okay, I just wanted to describe a bit how the real application looks like, because I shown you the picture of the iceberg and that's all, but the real application looks like some 3-layer pie, because we have very typical and very popular 3-tier architecture of the application that is used in many companies for their software implementation. And this is just the brief description of this architecture, because Fedor, I'm sure that Fedor will describe you more detailed on his course. But this 10% of iceberg that you saw on the previous slide, this is a presentation tier. The topmost level of the application is the user interface, how says this description here in the picture. And the iceberg under the water is typically divided into 2 layers, 2 tiers: logic layer or business logic. We can call it business logic, or backend. Typically, this is the same, not in all the cases, but never mind for now. So let it be the same for now. And the data tier with some database or databases. This is the most typical situation for now, when we have different databases with different information. One type of the information is stored in one database, another type of the information in another database, and some information can be stored in the cloud and some other storage. But anyway, we are separating the layer that is working with the user interface only and nothing more. Separating the layer that is working with only the logic. So, for example, we are showing here date of birth, for example. Imagine that you are registering somewhere on the site and they ask you about your birthday. You are entering your birthday, and what else with the application? What is happening after it? On the presentation layer, you have this field, probably the calendar one. You are choosing your birthday, or you are entering it manually to this field, and together with that, your backend, your business logic tier, is trying to check, is that correct? Even if you are choosing from a calendar, you can say that you now have 200 years old, and probably this is not true, because I don't know about you, but I don't know anybody with the age of 200. Probably this is not the correct date. Maybe you made a mistake, maybe you are kidding, but you cannot be registered with this birthday. This is the responsibility of the business logic. And the responsibility of data tier of this database layer, this is the same, is to store your birthday somewhere in some table. If your birthday is correct and this logic tier says that everything is okay and we can put this birthday to the database, it move this information to the next tier, as the next tier is saving this information to the database. And back, the database says to the business logic that everything is okay, the birthday is stored, and business logic provide this information to the presentation tier. And you see that, okay, you have a message that your birthday is successfully saved. So you provide your birthday, and after some parts of a second, you will have this this message. But during this very short time, a lot of things are happening with the application. So you can just now imagine what defects could we have if your birthday is not correct, or something with your database, or something with your logic tier, or something with your UI at least. And the other example, this is further slide as well from his spectacular webinar about the sandbox. I like it very much. Database issues could be, yeah, our application has been broken. Okay, something happened, we don't know what's happened, what to do. And we are now not only end users, but we are now testers. And the reason is not very obvious for us now. And what could happen if we have our application broken? Some database issues. Data seems to be incorrect. We should check it. If the data is actually incorrect or not. Crashes. Our DB application crashes, probably, but we are not sure right now. We are testers, we should check it. If this is the real reason of our something broken with on our application. Network could be broken. So we probably have a server somewhere, and we probably have a client somewhere, like client maybe on your desk, and server maybe in US, in some Texas state or somewhere. And the data are moving from the server to the client through the network. And if something broken with our network connection, we will have the result in our user interface. It is not a data tier, it is not a business logic tier, it's just a network. We can have a backend service issue, like configuration issues, like performance issues, like just REST or SOAP services issues. Probably something it is not providing to the next service. One service is communicating with other services. This first one should provide some information, for example, the name of the user, but it is not providing the name of the user, but the second service is waiting for this name of the user, and they cannot make friendship between each other, and we have this reason on the UI. And at least something wrong with our front end application. Users token is not valid anymore, for example. This is a UI issue. Or we are not refreshing the page, and we should refresh the page manually. Though in our requirements, we can read that the page should be refreshed automatically. This is a UI issue. This is not about the database. This is not about the network or services or database. I said already about the database. Okay, this is a front-end application issue. And important notes here that even completely different issues may look the same and have the similar symptoms or the same symptoms, but with the different reasons. And real world applications may have much more issues depending on the application itself. So you now probably see that our application is very complicated thing. It is not only the buttons and the fields on the user interface, it's only the 10% of our application, only the peak of the iceberg. And we are not the users, and we will be the testers. And the good, honest, like Fedor said, honest, true testers should know all these reasons, should be able to find the exact reason of every defect. Observe on the user interface or not observe on the user interface. And that's why we have so complicated course that will be starting from Linux. Before we will go further to the next topic, do you have questions about this one? Or you all are shocked and all are thinking why I choose this course, why I didn't buy some, I don't know, skill factory.
Oh, I think now it's pretty understandable.
Okay.
That's okay.
I just connected and we'll see tomorrow maybe.
Okay. Okay. So, if everything is understandable, you are a very smart group. Congratulations. And we can go further to testers' tasks. So, what are the testers' tasks really in reality? So, remember the time when you were regular humans who knew nothing about the tester's profession. And probably you thought about the testers like testers should find all the defects in the application, or even testers should corrupt the application. And probably the working day of any tester looks like he or she starts working and corrupt something and find a lot of defects, and he or she is very happy about it, and all the defects are written somewhere, I don't know where, or even he's happy about the corruption, he's happy about the destruction, everything, he's breaking all the things around. And this is a good tester. And if a tester cannot break everything, cannot corrupt the application, cannot find all the defects during one working day, this is not a good tester. And this tester is crying. He is trying to make a suicide or something. And now, after my previous speech, I think you already know that it's not true. So what is the tester's primary tasks? What is the mission of us as a testers? Okay, we typically start from application understanding. Even if we don't have right now the application itself, only the documentation about the application, only some conversation with the business, with analytics, with your lead, with developers. So you have the information about the application, and you should firstly to analyze the application, analyze the information about the application. What is the architecture of the application? What are the integrations of the application? What is this peak of the iceberg? What user will observe from the user interface? And what about the underwater part? What about this 90%? What is inside the application? You should collect this information, and then you should analyze, is this information enough for making a testing plan? I'm not talking about the test plan itself as a document right now. I will talk about the test plan further in the test documentation module. Now I'm talking about the plan, how you will be testing, and if the information enough for it. If you get that the information enough, or you got the information that was not in a first in an initial documentation or conversation, you could start planning your testing. You are not testing right now, just pay attention to it. You are just thinking, and this is your I think about 70% of true tester work is thinking how to do some things, and only 30% is testing itself. So you are planning the test cases, the environment configuration, the data preparation, how to combine all that together. What is the priorities of all that things? What is to be tested first? What is to be tested after that? And what time do you need to cover all that with your testing? You are still thinking. You probably didn't see the application yet. You are just having something in mind, and that's all. And when your plan is absolutely clear, when you clarified all the things with your stakeholders, with the people who cares about the project, who have the information about the project, you could start testing itself according to the plan. After our main course, probably we will talk about the exploratory testing. This is not according to the plan, but this is the separate branch. Don't think about it right now. You are testing according to your thoughts. And during the testing, you will see that reasons I was talking about previously. And your mission here is to find where the defect are placed in the application, and how to explain this place to your stakeholders, and how serious it will be for your customers. Remember about your end users and your customers. The impact will be high or not very high, okay, because of this defect. You collect all this information, you systematize all this information, and then with this information, you are going to stakeholders, to project managers, to test managers, to business owners, to product owners, and so on. So you are going to the people who cares with this information, and share this information with all that people. And you, with that stakeholders, make a decision about current application quality, having in mind all the information, having in mind the business impact, having in mind how sad your customer will be because of these problems you are sharing. And this is your primary mission. Don't not corrupting the application, not breaking everything around you, not finding all the defects. Your primary mission is to share the information about the current state of the application. If you cannot find any defect, it is okay. If you are sure in your experience, in your skills, of course, and if you are sure that you tried everything that you should try. If you cannot find any defect, okay, your developers are ideal, and your software is ideal, and this is the information as well. So you are going to your stakeholders and say that, okay, the software version is ideal, absolutely, I cannot find any defect. And this is the result as well. So this is your mission. Any questions about this? Okay.
So I'm sorry again for interrupting you. Can add several words regarding the mission of Google QA engineer and so on. Probably you have heard, or you will hear several words regarding penetration testing and another kinds of security testing. So I can say that software guys should have completely different mindset compared to a typical software engineer and to typical QA engineer. And for them, so they should be really enthusiasts to break something, to crash something. So to be the typical QA engineer as he is imagined by another guys. But again, I need to say that such job and such tasks to find some insecure points, vulnerabilities and misconfigurations and so on. It's a very specific domain and it really differs from typical activities in QA.
Mm-hmm. Thanks a lot for this remark. So guys, if you have passion to breaking everything around you, your way is pen testing. But to be serious, I'm sure that pen testers have plan as well, the same as functional testers. Am I right?
Simply yes. So we know that typical job implies very strict limitations of time and so on. So we need to do the most and the best in very shortened limits of time. So of course, even as for pen testers, there are several best practices and there are several way to go or instructions or how-tos and so on. So yes, it somehow resembles the typical test plans that is created by QA engineers, but how it can be said, they differ.
Mm-hmm. Okay, very interesting. So, any questions? Maybe after Fyodor's speech, there are some. No. Okay, so the information, how can it be used for further? Okay, so you are the testers, you are here. You collect the information about what problems does the application have, in which part of the application we have these problems, and if there a workaround. Yeah, I think you know what is workaround, when you have something broken, but you can get the result in any other way by workaround. And you are going with this information to your leads, managers, and other stakeholders like project managers, product owners, anybody. And what are they doing with this information? Firstly, they are collecting the metrics of the application testing, because you can say that everything is bad, and so the application is not good, and we cannot go to the users with this application. But this can be your particular opinion based on your personality. For example, you're a pessimist and everything is bad with the world around you any day. Or opposite case, you can be very optimistic and everything is good. Okay, we have some problems, but it's okay. We can go with this. We can live with this. Application crash. So what wrong with it? Crash? Not every time. So we should have some metrics, some objective thing to compare. And that's why we are counting all our defects. We are prioritizing all our defects. We have some special formulas to count everything, to compare everything with the quality gate, so-called. So to go to the production, we should pass this quality gate. For example, we should not have any critical defects. We should not have any blockers. We should all our features covered with the test cases, and all these test cases should be passed. This is only the example. It can be different from company to company, from project to project. But anyway, we have some objective metrics to compare with. And we are counting everything. I say we because I'm here already in this square where leads and managers lives. And we are collecting all that, comparing with that ideal quality gate, and we're making a decision: go, no go. We call it this way: go, no go means if we are going to the production with this version, if the release of the next version possible right now with this quality of the application. So we are not talking about that we should not have any defect in the application, and we should not have any problem. We have some gate that we should pass. If this gate is described as we can have 10 defects, not more, and we have only 9 defects, we will go to the release with this version. And probably you, as an end user, will use this application, and you will be very angry about these 9 defects, but the product owner or project manager or some business guy decided that 9 defects is okay. If the defects are in this and that particular functionality, it is okay. And you will be living with that 9 defects until the next version. Probably in the next version, the defects will be fixed, but it is not a fact. Maybe later, because this is not a priority right now. So this is like briefly abstract about the tester's life and what all this information about, and why we're sharing this information, and what are they doing with this information. Okay, I will be waiting a bit for questions. Okay, so again, to sum up the mission of testers, firstly, they should get the information about the application and its environment and integration. So to understand, deeply understand the application, where the problems can be, what is the architecture, what is it built from, what are the parts of this application. Then we are analyzing it and testing and collecting all the information about the current state of the application, and then share this information with the team and the customer, and waiting for the decision about go, no go. So this is our mission as functional testers. The same mission, pretty the same mission, automation testers have because the automation is very close to the manual testing, if we are talking about the approaches, but we are testing, okay, not we, manual testing, testing by hands manually, so by clicking the buttons, fields, and so on with your hand, with your mouse. And automated testers are doing the same, but with special scripts. But the mission is the same, because the automated testers are collecting the same information. They have some special reports from the automation, and they are analyzing these reports and sharing the information the same way. Okay, and we have the last topic for now about the development team and the structure and the people who are in this team. If we don't have any questions about the previous topics, we can go further. I will wait a bit. Okay, so this is a simple schema of how typical software project team looks like. Your particular team on your particular job could be a bit different from this, but this is like very often typical structure of the team. Firstly, we have some product owner who are all these people. I think I will show you the schema, and then we will go step by step. I will tell you about every person here, every role here, not person. So we have a product owner. This is the representative of business, of your customers. Even if you are doing some box product, you have customers, but inside your company. If you are doing some services for other companies, your business people will be outside your company. But anyway, you will have business and you will have some product owner, some representative of your business people who knows everything about the application. You will have the project manager who are managing everything and thinks about a lot of things, thinks about a lot of things connected, linked with the project. You have a development team. Just pay attention. We are saying development team, meaning not only developers itself, not only programmers itself, but every people who are involved to the implementation of the project, implementation of the software. Firstly, that are business analysts, designers, developers, QEs, of course, and DevOps. That's strange people, and nobody knows what are they doing. I'm kidding. Okay, so let's start from product owner itself and from the beginning. Okay, not very good quality of the picture, but probably you can read something here. Product owner is helping the development team to focus on some particular things that are priority right now. Because we have the application, we have the software people, they can recognize some tasks as very interesting and some other tasks as boring, and they can focus on wrong things. But if they will be focusing on wrong things, our project will not be in time and we will miss the deadlines, and that's very bad. So we should have somebody who helping to choose the tasks that have the highest priority for now, the features that we can implement for the first, and other features can wait a bit. And this product owner helping the development team to have these all tasks prioritized in some special place called backlog, product backlog. This is like a big box where all our tasks are laying, and we can take all these tasks from this big box, the product backlog. We have the Scrum Master here. This is not a mandatory role on the project, but it is often used if we using Agile, but in particular Scrum development methodology. This is a special guy who is organizing all the process and helping the team to follow the process every day. Everybody hates that people, but sometimes they could be useful when the development team are trying to do some wrong things or not follow the process. And if we are not following the process, our things will be slower, much more. Okay, why this product owner is useful for QEs? He's responsible, or she is responsible for QE task as well, and their prioritization as well. So we can ask the product owner about the prioritization of the task if we are not sure in it. So you have two tasks with the same priority, and you adapting what particular task is to take right now and to work on right now. And you can ask this guy to help. Okay. Project manager. Let's be back a bit to our scheme. This is the project manager. You can see that he or she is between product owner and the team. So he or she is not a part of the team itself, he or she is not implementing, he or she is not writing code, he or she is not testing, but his or her responsibility is to try to follow the plans, not the process, but the plans. Because at the beginning of the project, we have the scope. Let's be back to the slide. We have the scope. So what should we implement? What features should be in this scope, in this software right now? We have the time for these features to be implemented. So we have 5 features, for example, and we should implement these 5 features during 2 months. Not very typical project, but can be. And the budget. So we have money. So you probably wanna have some salary, and your colleagues as well, and probably you wanna have some beautiful office and so on and so on. So every project has a budget. So you should implement that 5 features during 2 months, and your customer should pay you, for example, $100,000 for this implementation. This is not a real sum, real money. Don't pay attention, just for example. Okay, and the primary task of the project manager is to save the balance between that 3 things. Not to miss some scope, not to miss the deadlines, and not to spend more money for this project than planned. And this is very difficult, just believe me. So that's why the project manager should constantly controlling everything on the project, should constantly controlling that we are still in the scope of this triangle, and he or she should identify risks every some time to be prepared for some problems if we will have some problems. So this is very hard work, and the project manager heads up for everything. This is the main thing. This is the very important thing. And for you is the guy who is controlling your QA tasks as well, that everything is performing in time, everything is performing according to the priorities, and he or she will come to you every day and ask if everything is okay. So this is your chief on the project. Okay, business and system analysts. We have business analyst here, but actually we have 2 types of analysts, business and system. This is very useful guy who is translating from business language to technical language, because business can come to your company and ask to do everything well, like create me a software with a button, and that's all. And the button probably could be pressed. I'm not sure, but probably. And analyst is asking that guy about the real needs, about the real things to do, and then translate everything into the technical language. And accept it, he or she is responsible for answering documentation questions that raised when QE is analyzing documentation, because the documentation can be not very good, and we have a lot of parameters how to assess the documentation. We will be back to this topic, of course, later in the course. But you every day you can ask any question to the analyst, to the business analyst who is responsible for business requirements, and system analyst who is responsible for technical requirements. What else? Designers, user experience or customer experience designers. This is dependent on from what points of view we are primarily looking, from user or from customer, so from point of view of getting money or from point of view of comfortability of working. Anyway, he or she is responsible for an interface of the application, for usability and customer user experience. Pay attention that he or she is responsible only for the pictures. So if you have a button that looks pretty good but is not working, the designers is okay. So designers did their work well because the button is beautiful, and the functionality of the button is the responsibility not only designers, not designers, but developers. And if we are talking about the developers, they can be very different. So we have a lot of branches of development, and saying about somebody he's a programmer, it is nothing. So you are a programmer, please repair my TV, like this. So the programmers, developers itself, can be architects, firstly, that are guys who are responsible for the whole architecture of the application. This is a guy who are choosing that three-tier architecture, for example, and what features should be linked with what layer of this application. In most cases, the architect is coming from developers. He was or she was a very good developer, and he or she can be able to understand the application as a whole, not only the part he or she is developing. And from this, he or she can grow to architect. So this is growing up adult, like the programmer developer. Not so adult developers could be web UI or front end, services backend, depending on the responsibility and depending on the layer they are developing. They could develop mobile or game dev or database, and the last one called database analysts. And they are very useful for you as well, because QAs can ask questions about technical implementation possibilities, and you are very useful for them because you are checking their work and you are creating defects for them, and you are helping their work to be perfect. And remember about this, don't be in confrontation with developers. You should be friends, and you should be doing the same business, the same big thing. You are helping each other. What else? DevOps. This is the newest specialization, I think. In maybe the newest is desktops, but okay, one of the newest specialization in IT. This is the hybrid of developers and operators. Developers are responsible for application performance and user analytics, quality code levelers. You can see it here on the picture. But in reality, briefly saying, the DevOps says make environments work. So all this environment we were talking on the one of the first slides when Vyacheslav asked me. This is the responsibility of DevOps primarily. To not to think about this environment, but to configure everything, to configure the operating system, configure the clouds, the application, to choose the correct version of the application, to configure the automation tests on the test environments, to configure the unit tests jobs on the test environment. So the DevOps is helping you to get everything work. And you can think only about the functionality of the application and the integration. You will not thinking about how to configure the test environment, how to prepare your platform, because you have the DevOps. So this is a very, very, very useful guy. And these guys are like rare. Not all the projects can have this DevOps. They are expensive and they are rare. So if your project has DevOps, you are very lucky, because you will not doing all that things yourself. And at last, we have testers. Probably you already guessed that the testers can be very different. We have functionality testing, we have user experience testing, performance and load tester, and security or pen tester testing, further already said about. Compatibility testing, and that are not all the testing types that we have, only the examples. And you should help each other as well. And that's all for now. If you have questions about this particular part, please feel free to ask right now.
As I understood, it was like some introducing to the Scrum model. Yeah.
Not Scrum, because this model can be applied to any other methodology. If you have okay, so if you are talking about this particular slide, where we have the Scrum Master, this is the Scrum, yes. But if we are talking about the other roles, for example, we don't have project manager in Scrum model at all. We have the Scrum Master there. But as for the waterfall, as for the V model, as for the spiral model, we will have the project manager there. So I described you different roles. But as for the particular models, particular methodology of software development, we will talk about it later in the course. And we will stay a bit detailed on the Scrum as well, because this is the most often used methodology right now. As for business analysts and developers and DevOps and designers and QEs, we can have these roles in every methodology, including the waterfall. But in the waterfall, we will have the testers only on some stage of the process, and we will not have business analysts there together with the testers.
Okay, thank you.
Okay. Any other questions?
Lilia, when you talked about project manager, PM, I remembered that there is also product manager who is also PM. What is the difference between them?
Okay, the project manager is responsible for controlling on the project and responsible for staying in the scope of features, budget, and the time. Okay, so he is responsible to have everything in time. But the product manager is like the product owner, very similar to it. This is the guy who is responsible for how does it call? Responsible to make the software according to the business needs, to the things that business really wants. So product manager is staying on the point of view of business and controlling that we are doing the things that business really needs. Okay.
So I can add here that as for my experience, compare the two project managers. When we speak about product managers, such role is not so exact, such role is not so exactly defined, and it can really differs from one company to another company, which responsibilities are included in such role. So as for my company, as for Acronis, I can say that in our company, our product managers have very many different tasks assigned, and I'm not sure whether such experience is good. But anyway, mostly I'm agree with my colleague that such guys like product managers are responsible to several things, like, for example, competitive analysis, like market analysis, and they need to ensure that what we are doing is really required for the market.
Okay, thank you, Fedor. Just to comment a bit. In some companies, some roles could be combined. So even if some guy is on product manager role, that he or she could be responsible for real product manager task, but the tasks could be combined with other tasks for other role that could be called differently, for example, but we don't have a guy for this particular role. So our product manager, we decided that he or she is very similar to that, and he or she could combine the two roles and still called product manager. So IT is very, very various. So we can have different cases in different companies, really.
Okay, thank you.
Thank you for the question. Any other?
Yeah, I have one more question about testers, about differences of their functions. As I understand, that depends on scale of the company, because I think in a smaller company, one tester do more these abilities and more scale, less your differences in some functions. Is that right or not?
Yeah, you're absolutely right, because if you are working for some startup, you probably will do everything, including development as well. Right before I started the lecture, so why I'm so late today, I participated in pre-sale meeting for some startup company who wanted to hire my company as a QA service, and they described their current process as okay, we are developers here, and we know nothing about the QA, but we are doing the QA job. Okay, our QA job is to write the unit tests, and then we are testing something on the production. So, but we are growing up right now, and we decided to hire some testers for our tasks. But right now we are doing everything. So you can really meet some companies who which are responsible for everything, which where people are responsible for everything, and where they have only one tester who is doing everything regarding the testing. But if the company is mature, if the company is big enough, we will have a division between different types of testers, because everybody understands that the best result will be if specialist is concentrated on something. Okay. Did I ask?
Yeah, thank you.
Okay. Anything else, guys? Okay, I think that that's all for now from you. So I want to sum up our lectures for today, and then I describe you your homework. Okay, what did we learn today? Firstly, that we should base on customer needs if we are speaking about quality. We should remember the phrase that quality is the value for some person. If we see the discrepancy with the requirements and it decreases quality for our customers, we are saying about the defect. The defect connected with the requirements have the highest priority. We told about the development team, and we considered that development team consists of managers, programmers, DevOps, testers, and other people. And to sum up everything and to open our course, I can say that testers may have very different skills and very different specializations, but the basics of manual testing is mandatory for everybody. And that's why our course is about the manual functional testing, because this is the base for you. And that's all for now. Your homework. Your homework will be in the Get course together with this recording and together with this presentation, and maybe a bit unexpected from you, but this is present from us. Before every lecture or every set of lectures, we will have, you will have from us the text version. Some, not maybe a book, but some text document with a description that you should read at home, understand, maybe Google something if you are interested in. It is not mandatory to Google, but if you are interested in, you may Google. And next time we will be discussing that text, and please prepare your questions. And I think, and all our mentors think the same, that that will be more productive, more efficient for you to get all the knowledge from me. This lecture is the first one, and that's why you will get your text version after the lecture, so it will be in the Get course as well. Except that I found an interesting article about the project roles, and you can read some more about the project team roles there. The next one is the start of our Linux model by Fyodor, who is together with us today, and it's very good. His text introduction will be uploaded tomorrow, and this reading is mandatory. And one more homework from me is to analyze these old style pictures about the tree. I guess that this picture is from Fido, maybe from Fido time. Do you know what is Fido? This is the beginning of the internet. You should analyze this picture and try to apply all the knowledge from today's lecture to this picture. And answer the question, what if QE participated in the development of the swing here? How they could help? Please consider all the stages of the process and describe your vision, how the QE participation could help here, and put your answers to the GET course. Link it with this particular lesson. Okay? Questions?
I have a question about the last task. Now, I don't fully understand how it particularly works with home task. It's like comment under the course, or to send a file with the answer?
It's up to you. If it is more convenient for you to send the file, please send the file. If you prefer commenting the lesson, please comment. So for me, it doesn't matter.
Okay.
Because Get course is convenient enough. It supports text, it supports pictures in the comments, so you can use comments. Or you can use files if it is more convenient for you.
Okay.
And as for point 3, I may add that I will send you your open VPN certificates for connection to our test lab by tomorrow evening. So to let you connect to our lab by the evening, and it also will be coupled with our instruction of how to connect by using OpenVPN, and of course you will have some theory just for the next lesson and some small exercise.
Okay. So if nobody has question right now, so we can go to have some rest. Thank you very much for everybody for participating in today's lecture, and see you on Monday. Fyodor will see you on Monday, not me.
Yeah, sure. So have a nice evening, and see you on the next week. And please look from time to time to our Telegram chat, so some announcements and another important items will be written here.
Okay, have a nice one. Thank you.
Thank you very much. Bye-bye.
Yeah. Thank you, everybody.
Thank you very much.
Have a nice evening.
Bye-bye.